On our last or previous class, we treated fundamental quantities and fundamental units. So today we are going to focus more on derived quantities. So, what are derived quantities? Derived quantities are quantities that can be expressed in terms of fundamental quantities. Full stop. They can be obtained by simple combination of fundamental quantities and units. So, derived quantities are quantities that can be expressed in terms of fundamental quantities. They can be gotten by simple combination of fundamental quantities and units. For example, we have derived quantities. Then we have unit derivation. Number one of the derived quantities is length. Sorry, number one is area. So remember that area is length times width. Area is length times width. For example, look up. Let us consider a rectangle surface or rectangular surface. This point is A, this point is B, this point is C, this point is D. From this A to this B is length. And from this point C to this point D is length. This AC is width, and this BD is width. So the area of this rectangular surface is area equal to length times width. So that is why we have length here and we have what? Width here. So if you want to derive the units now, remember that you now consider the units of length. From here to here, what's the unit? From here to here is measured in meter. From here to here is measured in what? Meter. So in other words, it means that length is measured in meter, while width is measured in what? Meter. So meter multiplied by meter according to indices, remember that this, you have m here, you have m here, you take one m, they are common. Then the power of this m is 1. The power of this m is 1. So according to indices, multiplication changes toward addition. Since that you have multiplication sign here, you're going to have 1 plus 1. That means you're going to add the power together. So giving you what? M raised power what? 2. 1 plus 1 is 2. So that we have m raised power what? 2 as the SI unit of what? Area. Then number 2, we have what we call volume. Number 2, we have volume. Volume is length times width times height. So let's consider rectangular solid. This is height, this is length, and this is width. So the volume of this is length times width times what? Height. So length is measured in what? Meter. The width is measured in what? Meter. The height is measured in what? Meter. Then according to indices, you have how many m here? 1, 2, 3. You take 1, they are common. Then according to indices, multiplication changes toward addition. So that you have 1 plus 1 plus 1, giving you m raised power 3. So you have meter cube. Then number 3, velocity. Number 3 on our list, velocity. Velocity is displacement all over time. So in other words, you have that v is equal to d over what? T. Now d is measured in what? Meter. T is measured in what? Seconds. You have the SI need to be what? Meter per second or meter per second. Then you have number 4. Number 4 is acceleration. Acceleration is change in velocity all over what? Time. Acceleration is change in velocity all over what? Time. So we have that A, change in velocity means the final velocity minus initial velocity divided by what? T. So when final velocity, when the initial velocity is 0, you have v minus 0 divided by time, giving you what? V over what? Time. So if, look up here, if acceleration is equal to v velocity over what? Time. Now what is the unit? Velocity is measured in meter per seconds, while time is measured in what? Seconds. So when you have, remember, you have x here, you have x here. These seconds up here, there's another seconds down here. So you cannot cancel these seconds and this one, because this seconds up here has -1, while this one have +1. So you can't cancel. So what are you going to do? You apply indices there. You're going to have m raised power. So you're going to have m x raised to the power 1 divided by x. So we are now turning this division into this. So you have s here, you have s here, you have m raised to the power x, m x raised to the power 1 raised to the power minus 1. Why? Because according to indices, division changes towards subtraction. So once we have one s here, you have another s here, you're going to take one s. That is why we have mx raised to the power minus 1. The power of this s here is minus 1, while the power of this x here is 1. So division is what? Minus. So you're having m raised to the power. So you're having ms raised to the power minus what? 2. Minus 1 is minus 2. So the SI unit is what? Meter per second squared, or meter per second squared. The SI unit of acceleration. Then we have number 5. So we have number 5 on our list. We have what we call density. Density. Density is mass over volume. Mass over volume. So you have mass is measured in what? Kg. Volume is measured in what? Meter cube. Look at it here. So the SI unit of density is kilogram per meter cube, or kilogram per meter cube. Then we have number 5. Force. We have number 5, force. Force is mass times acceleration. So force is ma. So if mass is measured in kg, acceleration is measured in what? Meter per second squared. You have the unit to be what? Kilogram meter per second squared, or Newton. Then we have number 6 on our list. Power. Power. Power is work done divided by time. So in other words, power is W divided by T, or you can say energy over time. Now, what is the SI unit of energy? Energy is measured in what? Joules. What of time? Time is measured in what? Seconds. You have the SI unit of power to be what? Joules seconds. Joules per second, or joules per second, like this. Or you can measure power in watts. That is why you have 60 watts of bulb, and so on and so forth. So let's move to number 7. I'm going to clean this side. Number 7. Number 7 on our list is work. Work is force times distance. Work is force times distance. So what does that mean? Work is said to be done. Work is said to be done when a force moves an object towards a distance in the direction of that force. So for work to be done in physics, there must be force and there must be what? Distance. Force is measured in what? Force is measured in Newton. Distance is measured in what? Meter. So the SI unit of work is Newton meter. Newton meter. Or work can be measured in joules. Then we have number 8 on our list. Momentum. Momentum. Momentum is the product of mass and velocity. Momentum is the product of mass times velocity. So mass is measured in what? Kg. Velocity is measured in what? Meter per second. Then when you combine these two, you are going to have kilogram meter per second. Then we have number 9, impulse. 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 Impulse is the product of force and time. Impulse is force times time. So force is measured in what? Newton. Time is measured in what? Seconds. You're going to have Newton seconds as the SI unit of impulse. Then we have number 10. Number 10 on our list is pressure. Pressure. Pressure is force over area. Pressure is force over area. So force is measured in Newton. Area is measured in meter squared. So you have the unit as Newton per meter squared or Newton per meter squared. You can even measure pressure in Pascal, etc. Then number 11 on our list. Let's clean this side. Number 11 is frequency. Frequency is number of oscillation all over time. So frequency can be measured in hertz or per second. Then the final one on our list is moment. moment. Moment is force times perpendicular distance, because of space here. Force times perpendicular distance. So a force is measured in what? Newton. Distance, this is distance. Perpendicular distance is measured in what? Meter. So you have the unit to be what? Newton meter. Newton meter. So moment and work has the same SI unit. Moment is measured in what? Newton meter. While work is measured in Newton meter. So both of them has the same SI unit. So these are the derived quantities, and these are the derived units. So without these derived quantities, you cannot be able to solve physics calculations. So I urge you guys to go through all these derived quantities, learn them one after the other if you want to excel in physics calculation. See you next time in our next video. Thank you so much.